Exponential functions. You guys are going to learn how to solve exponential functions with real-world applications. You guys have kind of already done this a little bit when we were doing compound interest and geometric sequences and series. And so some of the same skills that we have from that, which were first semester, are going to come back into play with your exponential functions, okay? So we're going to talk about how you solve an exponential function, which is going to be basically a review of how we solve them back in those sections. And we're also going to look at the graph of an exponential function. And then we'll get to some real-world applications of where you see exponential functions. And that's going to kind of be how your homework is based. Your homework is based on your applications of exponential functions. Okay? So how do you use the different properties? So what makes a function an exponential function is because your variable is in the exponent, okay? So it's not like x squared where the squared is the exponent. No, it's something similar like 2 to the x or 3 to the x. Okay, so an exponential function is a function in which the variable appears in the exponent. And so when we solve these out, you guys in A and I are only required to know how to do it using your calculator. Yes, you can do this using logs if you remember how to use logs. But we're going to use our calculator to solve this, okay? And I know it's very pixelated on my end, but you have it nice and clear in your notes, okay? So this is when we go into our calculator. Y'all remember how to do this?
No.
All right, some no's, some yeses. Okay, so we go into our calculator. We go to y equals. And remember, we do the left side in y1, the right side in y2. And we're looking where the two curves what? Where they intersect, okay? So that's going to be 3 to the x. And so you press the caret button. And that's how you get the exponent. You put an x there. And then you'll put 7 in y2. And then remember, I don't know what we did in our calculators last, so how do I go back to a regular window? Zoom 6. Very good. So zoom 6. And my blue will be my exponential function. And then my red would be 7. There it is. Now, if you wanted to provide any other type of work to go along with this, because there's very little work when you do use your calculator, you can provide a sketch of this graph. That could be considered a method. Okay? So, if you wanted to, you could provide a graph of an exponential function. So there's the 3 to the x, and then here's the line of y equals 7. It's literally what you see on your calculator screen, and we're looking for this point right here. Now, because it's asking us to solve, we don't want the full coordinate. We only want the value for what? X. Because technically when you solve this, it wouldn't be just x equals, so we only want the x value, not the coordinate, because we're solving. So there's a difference. So, how do I get that intersection point? Second trace. Option 5. And because an exponential and a line are only going to intersect at one point, you'll do enter, enter, enter. So my solution is x equals 1.77. 3 significant figures. And that's how you'll solve these exponential functions, okay? Left side into y1, right side into y2. We never write that, okay? And then we look for the intersection. Question? So then let's get to the bulk, the beef of an exponential function and what it looks like, okay? Follow along with me. Don't go ahead. It might be tempting. Follow along with me. So the general form for an exponential function is y equals k times a to the x plus c, and y equals k times a to the negative x plus c. Those are the two different types of forms that you guys are going to deal with in A and I when it comes to an exponential function. This is an example of an exponential function, 2 to the x. So a can be any number. X is your exponent. Okay? And the c, whatever value is being added at the end, that c is always your y-intercept. Okay? That c is always your y-intercept. Quick correction, and the c serves as the horizontal asymptote. With every exponential function, you're going to have a horizontal asymptote. And if exponential function is this 2 to the x. Is there any value that I could plug in for x that's going to give me a negative y value? Like if I were to plug in any number, like if I plug in 2, that gives me 4, right? 3, 8, 4, 16, so on and so forth. If I plug in negative 1, is that going to give me a negative y value? No, it's going to give you 1 over 2. If I plug in negative 2, what's that going to give me? 1 over 4. It's never going to actually be a negative y value. So that c, that number that's being added to the base, that's always going to represent your horizontal asymptote. Okay, that's going to be the lowest that graph is going to go. No, it will not always be 0, because if you had a plus 2, this graph has now been shifted up 2 units, which means the lowest that it's ever going to go is 2. It's never going to cross or touch 2. It's going to get really, really close, but never actually be that value. Okay?
So that will never touch 0.
So that will never touch 0. It may look like it. Okay, it may look like it on your graph, like here, 3 to the x. It looks like it touches 0, but if I were to trace that function, okay, like look at my y values. If it ever moves, there it goes. Look at my y values. You see how small they're getting? That just means scientific notation. That's 0.0007 da 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 da. It'll get very close to 0, but it'll never actually be 0. Follow me? So the equation for the horizontal asymptote is y equals c. It is an equation, so please make sure that you write it as such. Horizontal is y equals. X equals is vertical, like your axis of symmetry. Both a and k affect how the graph will either increase or how it will decrease. Okay? So that number that's attached to the base of a, will tell it whether it's going to go up or go down. More specifically, k will determine if the graph lies above the asymptote or below the asymptote. Reason why is if k were to be negative, that means the graph has now been flipped over and is now below that asymptote. And then with these types of functions, especially when you're looking at models, you're either going to have an exponential growth or decay. Growth like population growth, decay like if there's a virus and people are dying, population is decreasing. You'll know whether it's going to go up or go down depending on the value of a. If a is greater than 1, it's going to increase. A was 2 in this case, so it went up. But if a is in between 0 and 1, it's going to decrease. Questions on the properties of exponential functions?
It can't be below 0.
For this, like a problem like this, it won't be below 0. However, depending on your function, let's say this was a minus 2 instead, it would go below the x-axis, but it won't go no lower than negative 2. So whatever the c value is, it's going to be like the lowest point that graph can go. So let's get to some examples. Okay, let's get to some examples. These are very similar to the types of problems that you're going to get in IB. Okay, it says the graph alongside shows the curve of y equals k times 2 to the x plus c, where k and c are constants. We're asked to find the value of k and the value of c, and then once we find those, we want to find what the value of y is when x is 6. So let's take a look at our graph here. Okay, we have 2 points on this graph. We have 2, 10, and we have one other point. What's that other point?
0, -5.
0, -5, the y-intercept. Now remember, just like when we were doing quadratics, if we're ever trying to find a variable inside of our equation, we use a point. Okay? So we're going to use that 2, 10. We're going to plug 2 in for x and 10 in for y. So that gives us 10 equals k times 2 to the second power plus c. 2 to the second power is what? 4. So really and truly, we have 10 equals 4k plus c. Not going to be able to solve any, yes? No, C is your horizontal asymptote. So we don't know what that is just yet. We don't know what's that lowest value. But 10 is the y coordinate when x is 2. Can't solve for k or c in this case. But I can use this other point to do the same thing. Plug in -5 for y, 0 for x, and what's 2 to the 0 power? 1. So this becomes -5 equals 1k plus c. What do you have right here? So it's a system of equations, which means we can plug it into polysomalt 2 back in our calculator. This is a lot of review in this lesson already. Okay? How do we get to the feature that allows us to solve this system? Apps. Option 4, that's my polysomalt. So it basically stands for polynomial simultaneous equation. Which one am I going to?
2.
Option 2. How many equations?
2.
How many unknowns? Very good. Now I go to next. What's going to go here? 4. 1. And 10. My next line? 1. 1, 1, -5. Then I go to solve. What does x1 represent in my equation? K. And x2? C. So k is 5 and c is -10. So then that means that my horizontal asymptote is y equals -10. I know it didn't ask this, but I'm kind of trying to harp on some different features and properties. Okay? And k is a positive number, so that's just causing it also to be above the asymptote. Remember, if you try to do it with the matrix, so let me get out of this. Okay, remember with the matrix, you go to second x to the -1. You have to edit your matrix. It is a 2 by 2, and you include the variable side. So then that's going to be 4 and 1, 1 and 1. Then second x to the -1 again, you got to go to matrix B. That's where you're going to type in the left side. So 2 by 1, so that's 10 and -5. Okay, and remember this is when you have to do matrix A, -1, matrix B. And you get the same thing. So now that we know what K and C is, we can actually answer part B because our equation now becomes y equals 5 times 2 to the x power minus 10. So we use our value of K and C, and now we're looking for y when x is 6. So all we have to do is plug 6 in and solve. Let's go ahead and do that. And let me know what y equals. 310? Confirmation? 310, very good. So that basically, when you plug in 6, you're finding the corresponding y value that goes along with 6. So that means on your graph, when x is 6, y is 310. So that means. Let's look at the next example, an application. Very fuzzy up here, but you have it nice and clear in your notes. An entomologist monitoring a grasshopper plague notices that the area affected by the grasshoppers is given by an equation. A of n equals 1,000 times 1.15 to the n hectares, where n is the number of weeks after the initial observation. It's always good to make sure you are identifying what your variables represent. N is your number of weeks. And then A sub n represents your area, your hectares. Now, it's asking you to find the original affected area. The original affected area. How big was that? Original represents, what's another way to represent that?
N equals 0.
N equals 1.
It would be when n equals 0. Because since A sub n basically represents the area, if we're looking for the original area, that means we're looking for the starting area, the initial area. How big it was before, this plague took place. Okay? So this would be when n equals 0. So then we'll plug it in. So that gives me 1,000, 1.15 to the 0 power. So what's that?
That becomes 1 and then you multiply it by 1,000, so it's just 1,000.
So 1,000 hectares. Now part B is asking to find the affected area after 5 weeks and after 10 weeks.
Plug 5 and 10 in.
You just plug 5 and 10 in. So you guys go ahead and do that. Plug in 5, get an answer. Plug in 10, get an answer. Now I have no doubt that you're probably going to get a decimal, so you want to make sure you round to 3 significant figures. So when you plug in 5, what you get?
2011.
Is it 2011, 2010?
That was 2010.
It's going to be 2010 because you cannot make up for that, what? Now 65.65. Heck, whoa. Yeah. Oh, 3 significant figures. So then we'll go 1, 2, 3. But that 1 is going to cause us to keep this at a 1. And so we'll put the placeholder then of a 0. What about when we plug in 10? 4, 0. 4, 0.
4, 5. Wait, no. 4, 0.
5, 0.
Oh, okay.
4, 0, 5, 0. So let's take a look at that just real quick. You go 4, 0, 4, 5, dot, dot, dot. That's 1, 2, 3. The 5 causes you to round up the 4, but you need a placeholder for that 5. All right, C says we're going to draw a graph of the affected area over time. Okay? Draw. Draw is very different from a sketch. Okay, a sketch is just, give me a general idea of what the graph looks like. Draw means you need to highlight and identify some major things. It's an exponential function. So that means we should at least have a horizontal asymptote. We should have a y-intercept. And we should definitely make sure we're curving in the correct fashion. Now, in your homework, I'm actually going to give you a scale. And I'm going to give you the centimeter paper again. So, I want a little bit more specific. Maybe even plot 5, 20, 10, and 10, 40, 50. Okay? I don't got that much space here, so I'm going to do the best that I can. I only need a positive axis for my x and my y because I'm representing weeks. And I'm representing hectares. Always make sure you label your x and y axes. What is my horizontal asymptote?
If it's 0, it'd be 1,000.
No.
Wait, no. That would be
It is 0 because your horizontal asymptote is always your c, the constant that's being added. So I have a horizontal asymptote at y equals 0.
I was thinking white.
No, the curve can never touch 0 when your horizontal asymptote is 0. But the horizontal asymptote could be 0. Since there's nothing being added here, that is your horizontal asymptote. The graph will get very close to 0 but never cross or touch it. When n equals 0, My y-intercept, what was that value?
1,000.
1,000. Actually, I'm going to put that a little bit lower.
I got horizontal asymptote and y-intercept mixed up.
So we want to be very careful. So then we have 5 weeks, 10 weeks. We know at 5 weeks we're at 2010. And we know at 10 weeks we are at 40-50 roughly. So this graph is going to increase or decrease? Increase. So it's going to cross through the 1,000 and it's going to continue to go up. So we want to make sure that we highlight key features when it asks us to draw an exponential function. Now we have to use our graph or technology to find how long it would take for the affected area to reach 8,000 hectares.
So we just plug 8,000 to 8.
Very good. So using technology, slightly algebraically, you would plug 8,000 in for a sub n, and then we can go back to our calculator feature. Oops. I'm looking for this. To find the value of n. So I go to y equals 8,000 for y1, the equation for y2, and it doesn't matter, they could be backwards. You can put the equation in. Now am I going to use n or am I going to use x? X. And I'm going to have to change the window. Just by looking at the drawing that we've done, we can kind of use that to help us. Okay? So let's go to our window. What should my x-min be? What does x represent in our problem? Weeks. Can I have negative weeks?
No.
So 0. Now in my max, I know that at 10 weeks I'm at 4,000. I need to get to 8,000. So if 10 weeks is 4,000, then what do you think I should open up my window, my x max to?
20.
Maybe 20? Okay.
21 to be safe.
Now my y-min. Y represents my area. Can I have negative area? So let's make that 0 for my min. And my max, I'm at least trying to see 8,000. So I should probably open it up to 10,000. That way I can at least see that full line of 8,000. So now when I graph, there's my 8,000, so I see that very clearly. And now here comes my curve. And I am looking for that intersection point. What part of the x of the intersection point? The x or the y?
Y. No, X.
You're looking for x because we're looking for the number of weeks it took or how long it took. So second trace, option 5, enter, enter, enter.
And we just round up.
Okay, so we have n is 14.87, and it's asking us to figure out how long. How long? What am I gonna put?
How long it would-
15. Would you round it all the way up? Because does it want like a whole number of weeks?
Since it doesn't ask for a whole number of weeks, we want to just go ahead and use our 3 significant figures. So 14.9 weeks. Example 4. Now this graph shows the amount of water in a tank T minutes after it's punctured by a drill. So this right here, the x-axis represents time, and then A represents the amount of water in the tank. Clearly, if you puncture a hole, the amount of water is going to decrease, hence why it's going down. This is an example of a decay function, okay? And it says, find the exponential model that connects A and T together. So right here, very hard to see, but we have K times E to the negative 0.5 T plus C. Yes? Okay.
It doesn't say what E, like about E.
Yes. So now E, now let's talk about what E is very quickly. Let's let's talk about what E is very quickly. Okay? E is, missed the slide, but it's okay. E is a special number in mathematics. Okay, it is a special type of exponential function, as you can see. It is used mostly in science, engineering, and financial types of problems. And E is about the number 2.71828, so on and so forth. It's irrational, so it has no repeating pattern, and it never ends. Okay, there is a feature in your calculator that allows you to get E, and you get that by pressing the second button and then the ln button. And then that's how you get E to any power. You just type it in from there. This graph here shows you that E is, again, in between 2 to the x and 3 to the x because it's a little bit bigger than 2, but less than 3. Okay? So it is an exponential, it's a special type of exponential function, and it is used in application problems like the one that we were just working on. Okay? So we have to find the exponential model that connects A and T together. In other words, we have to figure out what is K and C. Okay? So in order to do that, we need to look at our graph. And we see how we have A equals 3 right here. What does A equal 3 represent? The horizontal asymptote, which is also our C in our equation. So right now we have A equals K times E to the negative 0.5 T plus 3. Your horizontal asymptote is always C. How do I find K? Remember, how do I find any variable in an equation? I need what? I need a point. What point do we have on this graph?
0, 10.
0, 10. We have our y-intercept. Okay, we have our initial amount of water at the start when this hole was punctured. So we're going to plug in 10 for A and 0 for T to find the value of K. What's 0 times negative 0.5? What's E to the 0 power?
2.7.
But anything to the 0 power is always 1. So this whole part goes away, and I'm just left with 10 equals K plus 3. So what's K?
7.
K is 7. So again, anytime I'm trying to find a variable in an equation, I use a point from my graph. So my equation is A equals 7 times E to the negative 0.5 T plus 3. Questions on that?
What does it mean connect A and T?
So we're looking for the actual equation that's gonna that basically has A and T in it. And so in this particular case, we had the equation, we have the general form, but we just need to find out those missing pieces to actually create our full equation. Now, do you think the hole is at the bottom of the tank or on the side?
Side.
Why?
If it's on the bottom, then the horizontal asymptote would drop to 0, wouldn't it? If it's 3, then it would have to stop somewhere.
Exactly. And also think about it. The lowest amount of water that's going to be left in the tank is going to be 3, which means that it's not completely going to be empty, even though there's a puncture. Okay? So, the puncture's on the side because you can easily say if it were on the bottom, then that means your horizontal asymptote would be at 0. But because it's at 3, that means you're still going to have water left over. Anytime you're ever asked to justify or explain, there should be some mathematical something in your response, okay? Whether it's the actual work that justifies your answer, or in this case, the horizontal asymptote and this numerical value that justifies why it was on the side. They don't want a long paragraph of a whole bunch of words. They need the number mathematically that's associated with it or the work that justifies why you say what you said. Now find the amount of water in the tank after 2 minutes. That's an easy one. All I have to do is what? Plug 2 in for T. So I have my equation. Plug in 2 for T. And I use my calculator to get my answer. So my area is 5.58 kiloliters. Kiloliters. Don't forget our units, kiloliters. Now, how long will it take for the tank to lose 6 kilometers of water?
Would you plug in 6 for A?
We would plug in for A, but are you sure it's 6?
Wait, no, because the max of the tank was 10, and we lose 6, so it'll be 4 actually.
So it'll be 4. Okay, because if we lose 6 kilometers of water, that means when we started at 10, we're now down to here. That's a loss of 6 kiloliters. So we're going to plug in not 6, but 4. And we're looking for T. So we'll do it again. Y1, Y2, see where they intersect. And I've done it a few times now to refresh your memory, so I trust you guys to be able to give me the answer. What'd you get?
3.89 minutes.
3.89 minutes. Did you put minutes?
Yeah, I'll put minutes.
Or get them units. You don't need to lose the unit penalty. How's this going so far? All right. Okay. So this last example, we'll get it knocked out really quick, and then we'll have you guys start on your homework. When a diesel electric generator is switched off, the current dies away according to the formula I of T equals 24 times 0.25 T. Now, real quick, is this one going to increase or decrease? How do you know? Because you're losing amps. Things are dying away, so that means you're decreasing. All right, and also, look at your A value. Your A is less than 1, right? If it's in between 0 and 1, that means it's decay. T represents your time in seconds after the power is out. Find I of T when T equals 0, 1, 2, and 3. Simple enough, right? I of 0 is 24 amps, right? I of 1,
6 amps.
I of 2, I of 3. Now, what current flowed in the generator at the instant it was switched off? What's that mean? The instant it was switched off.
We're trying to find the original.
We're trying to find what do you mean the original?
Like, you know how the first example, it says something about find the original.
Mm-hmm.
Well, if time in seconds after the power is out, if you want it initial, it'd be 0.
Mm-hmm. So yes, you guys are both right. So if you're ever confused, it says when the generator is switched off, the current dies away. So it's basically telling you that when it's switched off, this is what happens with the current after that initial switch. Okay? So you've already figured that out, didn't you? So it's basically I of 0, which is 24 amps. Now you have to plot this graph, and then it's hence or otherwise, find how long it takes for the current to reach 4 amps. Okay? Now, plot the graph. Now these are very nice numbers to graph. So 1, 2, 3, 4. So then we have 24. Half of that is 12. Half of that is 6. 1, 2, 3, 4, 5, 6. Okay. So 0, 24. 1, 6. 1.5. What's my horizontal asymptote in this problem?
0.
Was there any plus anything? Nope. So you should definitely make sure that it does not cross or touch your x-axis. What am I missing in my picture?
You're missing what the labels of the x and y axis are.
Very good. This one was amps, and the x-axis was seconds. So if I'm looking to find how long it takes for the current to reach 4 amps, that technically means I'm looking for this point right here, where they intersect. But I'm going to do that using my calculator because it said or otherwise. So 4 equals 24.25 to the t power. What's my time?
1.29 seconds.
Very good. Okay, and if you look at my graph, it was in between 1 and 2, so that's pretty spot on. All right. Now, if the question says specifically to use your graph, then you want to make sure you use the graph to get your solution. The only time you should use your calculator or any other method is if it says otherwise, which is why we could use our calculator here. But that is how we do exponential functions. Okay. Exponential functions. Remember, the C represents your horizontal asymptote. The lowest the graph can go. Okay? Make sure that if you have the graph, you make sure you label correctly, and make sure that you, also put the labels in for your x and y axes. And make sure your numbers are on the actual axes. Okay? And other than that, I believe that's it.